Right. Hi, everybody. Hi, everybody. I'm Ian Bolton. I work at Arm as a developer relations manager. I'm here today to talk to you about Arm Performance Studio and how you can use it within Godot. We ran a very similar talk at GDC earlier this year in March, and it wasn't recorded. And we decided to come here and share it with Godot Engine developers, people who create games or they work at the foundation or volunteers and so on, to let you know how to use it yourselves and get it recorded. So yeah, it's a pleasure to be here, and let's get cracking because I've only got 25 minutes. So overview, what are we going to be talking about? Well, why even bother profiling? We're going to find out very shortly. Once we've decided that we want to profile, well, what are we going to profile? In this presentation, we're going to look at a benchmark. Normally, you'd be profiling your own games. How do we actually profile on a device? Quite straightforward once you can lay your hands on one, so we'll go into that. Then we'll talk about two of our tools. Streamline is a trace-based profiler that can show you what's going on the CPU cores, on the GPU, and so on. Then we'll show how to bring in the extension into Godot so that you can add extra counters and things like that. Then we'll look at Performance Advisor, which is a very useful tool for getting an overall view of what's going on with your game or your application. And then we'll look at what to do next. So, first up, you've made a game. Usually, sounds like most people aren't making games on mobile right now. So you're probably making a game for console or PC. But somebody's tempted you to try and put it on mobile. Hopefully me, hopefully somebody else has said, this game actually could work really well on mobile. The future of gaming is mobile. And you've been convinced, I want to try it on Android. Well, so you've got your game that's running well, a great user experience, great frames per second, and so on. Maybe your PC's running it fine. You know, you've got your own fan or other cooling system. You decide, right, I'm going to try it on mobile. So, you know, try it on mobile. Well, mobile is a very different beast. Usually it's system on chip, so you've got a CPU and a GPU all sharing the same chip. And what that means is that if the CPU is very busy, that could impact the GPU and vice versa. They tend to be passively cooled as well, unless you've got like some extra thing to add onto the back of your phone to cool it down. So it's a challenge. So your game originally might have been running at the frame rate you wanted, maybe 30, 60 frames per second. You try it on mobile, suddenly it's different. The other aspect is usually your PC or your console might be x86 based. Mobiles and tablets, I think pretty much 99.9% are all ARM-based CPUs. And ARM also make GPUs as well, but depending on the device, the GPU might not be made by ARM. But still, when you compile your game, it's going to map to a completely different instruction set. It's going to map to different, there's different caching, there'll be a different amount of memory and so on. So a game that runs fantastically on your Godot development machine or on whatever platform you're targeting, try it on mobile, it's going to behave differently. So what we need to do at that point is do some profiling. So today you're going to learn how to do that, providing you can get your hands on a device. You can then use our profiling tools to identify performance bottlenecks or areas that you can improve. And after you've spotted those, then you can go into trying to optimize the key parts to make it perform better on mobile. So that's why we would want to profile. What to profile? So probably most of you are working on games at the moment and you're really tempted by now to think, I'm going to try it on mobile. Maybe by the end of the presentation you will be. So you'd be profiling your game. Here what I've done is I've created a representative benchmark from some scenes created by GDQuest. So on the right there you can see 8 choices there. I've taken 4 of them and put those into a benchmark mode. So this very simple project, it's going to have 4 scenes. It's going to show each one for 10 seconds and then move on to the next, and then it's going to exit. So not much of a game, but useful for profiling. So let's have a preview of that. So on the left, we've got a kind of leafy type thing going on. It's animated normally, but you can't see it here. On On the right, we've got 1,000 small physics objects that gradually increase over time. Bottom left, we've got an interior scene, and then bottom right, it's part of what looks like quite a pretty game there, but this is just the scenery. So moving on, you've made your game now. You've decided, I want to export it for Android. How do I export the APK? It's very easy because Godot's a very user-friendly engine, right? Well, key thing is you've got to tick that box, the export with debug. If you don't do that, you can't profile it. Now, you might be wondering, maybe you've done debug builds elsewhere. If I choose debug, is it going to hurt performance? Is it going to cancel my optimizations out? And if you ask ChatGPT, it will say it does actually cancel them out. And then you say, are you sure? Because I've read that it doesn't. And it goes, oh yeah, actually, it doesn't. So the truth is, it does not affect performance. It just retains debug symbols, and it signs the app with a debug key so that when you plug your device in, you can actually get it on there to run. It stops you putting it on the Play Store, but yeah, you're able to run it on your device. So just make sure you choose export with debug. And then your device, so you've laid your hands on an Android device, you need to enable USB debugging, and by default there's some developer options that you can't find. That link there tells you how to find it for specific OSs, but generally you find the version number of the OS. You hit that like 7 times. It might be the build number actually. And it says, congratulations, you're a developer. It's that easy to be a developer now. And then you can choose USB debugging on. Then there's something called Android Debug Bridge, which comes with Android Studio. And you can use that to install the APK on your phone. Make sure you connect. Well, I mean, you can do it over Wi-Fi, but I prefer to just plug straight in. And then you'll get the APK on the phone. Ready to start profiling. So once it's on the phone, the next thing you need, on Performance Studio, it's free. Free as in beer, and also free as in, I don't know the other meaning. But anyway, yes, just go there and download it. You don't need to put an email address in. You just grab it, and it's available for Mac, Linux, Windows. So it runs on your Mac, Linux, or Windows machine, but it's going to be profiling on an Android device. So it's a suite of multiple tools. Streamline's the main one. This used to be called ARM Mobile Studio, but because we're now moving into servers and so on, and laptops, some of these tools will be running on there. They're being developed over time to give you the same kind of profile experience on other platforms. So Streamline's the main one. Performance Advisor gives you this overview. It spots areas where it says, oh, you might want to actually try this. This is a key area to boost performance. Frame Advisor is one way you can identify individual parts of a frame that are, different draw calls and so on. So you can identify areas to save effort there. And the Mali offline compiler, I won't delve into these, but they're more advanced. I mean, if no one's used any of these tools so far, then I don't think we should delve into those yet, but they are very powerful. Maybe some of you have used RenderDoc. We've got a branch of RenderDoc that specializes on ARM GPUs. So yeah, we're focusing on Streamline and Performance Advisor. Streamline, trace-based profiler. I'm just going to check what the time is, 10:54. Okay. So yeah, if we jump straight to this bit, it actually shows you how to set it up. So you fire up Streamline after you've installed ARM Performance Studio. You'll be able to see your device there. In this case, my colleague Albin made this. So he had a Vivo, so you can see that listed there. You can see that it knows about various debuggable APKs on the device. Here's our Godot for GD Quest 1. So you select your device, you select the application, make sure down the bottom you say capture ARM GPU profile, or otherwise you won't be getting all the GPU data. Hit start capture, that's going to launch your APK and start creating trace. And here's one that my colleague Albin made earlier. So at the top we can see the thermals, very nice, nothing terrible going on there, but you can imagine if you ran it for a long time, it's a very intensive application. Then you could end up seeing, it's throttling or even worse, and then it will scale back effort. We've got CPU activity on the different types of cores there. We've got, I can't scroll it down because it's a screenshot, but there's a lot more GPU things anyway. But at the top level, you can see how active it is and so on. So, is there anything sticking out right now here? Ooh, the CPU activity's gone up at that point. Wonder why that is. That's interesting. There's a spike down there. Again, what's happening there? And finally, the GPU activity has jumped up there. I kind of liken this profiling a bit to being a detective. So there's interesting clues here. Now we get to try and delve in and unravel the mystery. But before we do that, let's talk about the ARM Performance Studio integration for Godot. So if you search, you can just search ARM Performance actually in the asset library. You can grab this, download it, and then install it into your project. Put it in the add-ins folder, and then it will, all the correct bits will be found. So you can access it from GDScript or C#. You can create markers, annotations. You can capture events as well. And basically, in your game, you can choose all the things you want to be tracking, and those will appear in that streamline visualization. So you'll be able to map certain events or certain counters to, oh, the CPU's gone high when I've spawned my 100th baddie or whatever. It's open source, so what's nice about that is if you're not like fully loyal to Godot and maybe you're making your own engine as well, you can see how to, within your own engine, call into the APIs in Streamline. So you can add these features to other engines, for example. So yeah, the source is all there. And right, how do we use it? Well, we instantiate this Performance Studio object. We get a new one of those. And actually, you can have multiple of them or have a global one. In my example, it's just a global one. So let's look at the first bit. So here, what we've got is we've captured the start, which is in Norwegian notation. The start isn't 2 whatever billion seconds. It's 2 point something seconds. And again, there's another marker there around 9. So you can capture key points in your game. Maybe you've got the menu screen, maybe you've got cutscene and so on. So you can be marking those off, and then you could map those to the data that's being collected. And channels. So again, here you can kind of capture a region of what's going on. So in this case, on this thread, it's showing that this is handling NPC AI. And it's as simple as saying create channel and then annotate the channel with a name and then end the channel. Custom counters, yeah, this is one that I find very useful. So you can create a category, in this case the enemies category, and then we've got an enemies counter as well, which over time, as you spawn more enemies, just make sure you keep setting the new value of the counter, and now on here you can see a graph of that going up. Custom activity map. So this is a rather advanced feature that I'm going to skip over, looking at the time, actually. But it's definitely worth playing with, and there's a README that comes with the extension. So you can check that out in your own time. And but here's an example of it anyway. So we've kind of mapped the NPC AI, and then within there, other stuff going on. Oh, and there's like a special section down the bottom of Streamline where you can see all this stuff. Right, so now we can map this high CPU to the fact that we've got all of these objects been spawned in that second scene, all those balls and so on. So the CPU's gone up because of all of those objects. At least it seems there's a correlation there. We don't know 100% that it's definitely that, but probably a good chance. Then here we've gone into the last scene there, and there was a CPU spike because it's trying to load up that quite complicated scene. And that complicated scene ends up actually requiring quite a lot of GPU efforts. We can map that to there. So hopefully what I've illustrated here is that you've got the data, loads of data, and to map it to individual parts of your game will enable you to work out where to optimize. You don't want to optimize the whole thing. You've just got to optimize the areas that need the attention. Performance Advisor might actually be one to use first sometimes. So just to get a rough idea of how is my frame rate overall? Where am I bound? Am I bound by CPU, GPU, things like that? So this can be integrated into command line continuous integration systems. So providing you've got the device hooked up, this will automatically launch it, get you the data. So every night, if you wanted to do continuous builds, you could do that. Do runs every night, you'll get HTML or JSON output. Generating a report, you run some Python. This lives inside the ARM Performance Studio folder, a couple of levels down. You run that first, does the capture, stores it on your computer. Then you run this Streamline CLI, .exe if you're Windows, not .exe if you're Mac. And then it'll process it and make a report that looks like this. Quite handy, actually. So it gives you info at the top about the processors that are involved on the device, the CPUs, the GPUs. Gives you a summary of an average frame rate. It shows you where you're bounded. In this case, we're not really bound by too much, apart from the VSync over there. And we've got our frame rate analysis, which looks great until the second scene, where it's really dropped. And down the bottom, again, we can see that the frames per second, the FPS, was around 100, and then suddenly it really falls down. And that coincides with actually loads of cycles per frame, as you'd expect. If you're having to do that many cycles, you're not going to be able to keep your frame rate up. Now, the Godot extension, what that allows you to do is put regions in. So these are just markers, but because it's called region start or region end, these then are understood by the Performance Advisor tool, and you get this. So now we've still got that average, but we've broken it down now into different regions. And if this was a real report, I'd click on some of those to see the individual report for the individual parts. But I have kind of got a screenshot of one of them, the bad one. And so that's broken that down further. We've got more info there now. We can see very CPU bound. All of those physics objects have caused the issue there. And at the top right, again, if it was clickable, read our optimization advice. What it does is it analyzes all the issues that it might see, and it makes some recommendations like, you've got way too many draw calls, or you've got far too many vertices, things like that. So it points you at areas that you can target. So it does some of the detective work for you. Takes some of the fun out of it, I suppose. But yeah, you don't have to click on that if you want quite a challenge to solve the puzzle. And that is the end, and I've done that in about 20-ish minutes, which means I've got time for questions, I think. Yes. So what to do next? Nobody had used ARM tools before, apparently. Well, now you can all grab this. Whether you've got an Android device or not, at some point you're going to lay your hands on an Android device. Maybe a parent, maybe a grandparent, maybe a relative. Borrow their device and say, I'm working on a game. I want to see what it looks like on mobile. Come on. So if you want to see, borrow their phone. Get the debug settings, USB debugging, plug it in, export. It's that easy to export your game in Godot because of the multi-platform support. Try it out. Maybe investigate it together. So grab ARM Performance Studio. It's free. Now try the integration. Download that from the asset library. Again, easy peasy. Get the Android device. We've already talked about that. Maybe just buy one. Rather than borrow one, but hey, yeah, however you lay your hands on one, give it a shot. And then start profiling. You might find out something interesting about your game. There's a chance that maybe some issues that you are having on PC console, this could illuminate that. You know, if you're using the same code, maybe this can point you to areas where you are doing too much work, too much CPU, or too many draw calls, etc. So start profiling. And finally, whether you do all those other bits, actually, reach out to me. I'm interested to hear about what games you're making on Godot. I'm interested to know if you need any help with any of this, if you've got any feedback on the tools or the talk. And just generally, just share experiences. I'm developer relations, so I want to understand what you guys are doing, what your motivations are, what games you're working on, where you see the future going, what are your favorite platforms, all those kind of things. I'm interested to hear. So that's my email. You can also find me on LinkedIn. So thank you very much for listening. And now I've got a question section. Thank you. Guy there needs a microphone, probably. Or you can, yeah, walk up.
Yeah, so is there a minimum version of Android that's required for this Performance Studio to work? I believe Godot runs on Android 5 and up. But...
Android 5 might be a stretch, you know? Yeah, don't lay your hand on any old device, literally. I think probably a lot of game studios that we work with, they're kind of calling, say, Android 11 kind of the minimum that they'd be targeting nowadays. I'm fairly sure it's going to work okay on that.
Okay.
But yeah, when you go to download it, it should talk about like the specifications and so on. But that's a good question. Anybody else with a question? Oh, yeah.
Is there a way to sort of simulate profiles of phones that you don't have in hand for testing?
Ooh, simulate profiles. Yeah, I mean, I'm quite keen on making it possible for developers to do this without having a device. So something that I would love to get in play is maybe like a remote device farm. At ARM, we've got a device farm. We've got a room, it's cooled, it's got loads of devices in it and so on. I'd love for us to create something that maybe people could run their games remotely on like we do at work. If there was the demand for that, I think maybe that's the kind of thing that might encourage more people to try it. So you would be able to remotely see your game running on a real device. But to actually simulate it, we do that in some sections of ARM as well, but we're talking like a really low-level trace. We don't do the kind of higher-level simulation. I don't know how useful it would be either.
Yeah, that sounds really difficult to do.
Yeah.
Even if there was like a fee though or a service, like I'd love to pay money to like rent an entire box of phones.
Yeah.
And just like churn through them and then mail back.
I think there are actually companies that offer that capability out there you could search for. But I'd love it if ARM could provide such a thing for people. And maybe if you join the ARM developer program, if you start contributing, I should really be plugging that actually. Yeah, look up ARM developer program as well. Sign up for that. We've got a Discord where you can ask questions on anything you're doing with ARM. Whether you're working on a little microcontroller or a single, like a little board or something, yeah, you can ask your questions there. And I was thinking maybe as you elevate your status in the developer program, maybe that would unlock the capability to remotely run on ARM devices. Who knows? But these are all ideas that if they're valuable to you, again, feedback. Let me know. If there's some blocker to getting a phone, maybe remote access could be the way. Any other questions? No, we're good. Thanks very much, everybody. Appreciate you attending. Thank you.